Today we're answering a subscriber question from Zeus Edwards. And the motherboard we're going to look at, we'll take a look here in a second. We've got a lot of information to cover. This got really deep. But we've got a lot of things that you may not have thought about that nobody else is talking about to the detail and level that we are. Let's take a look at the listing for the motherboard. And this video is about the Republic of Gamers Strix Z790 e-gaming Wi-Fi. Now this is going to be a motherboard overview of slots and storage for PCI Express resource allocations. And we're going to go down the path as we delve into these resources as is necessary and appropriate, because the specifications are going to be our outline. Now we're going to start with the motherboard manual, but we've got 4 pieces of documentation this time. Motherboard manual, BIOS manual, and 2 other lists. One for the Thunderbolt card for compatibility, and it's on there, but I want to show you. And the other link is going to be the ASUS BIOS bifurcation chart that we're going to share with you, compatibility. What we're looking for is congruent and corroborating information as we look at this, because on the surface we've got 3 slots, 5 M.2 drives, and we have, I believe, 4 SATA ports. Okay, the way those resources are arranged and allocated, there's going to be some give and take because we've got some shared resources. That on the surface things look good for 5 M.2 connectors, but when you look at the details of how that primary slot that's on the CPU, and we're going to separate CPU lanes from chipset lanes. So as we look at the motherboard, we have 3 slots and 5 M.2 connectors. And if you notice, all 3 of these slots look like they are 16-lane slots mechanically, which they are. However, electrically, only the primary slot is a 16-lane slot, and that's PCI Express with 16G5. The other 2 that are through the chipset are PCI Express E16, G4_1, and G4_2. Now, what's important about the G4_2 is right here on the edge of the board, I'll bring that up, right there is the Thunderbolt header. And the Thunderbolt card that would go in that slot will connect right there, what they call the 14-1 pin header. And for the M.2 drives, right here we can see this is M2_1, which is PCI Express 5, and right down here is M.2_2, which is PCI Express 4. Okay, that resource is to the CPU, and this top one is to the CPU. The other 3, M2_3, M2_4, and M2_5 are all through the chipset. And we're going to focus on this primary slot, that M.2 drive, and the M.2_2, because we have a shared resource. Now, I'll tell you in advance before I show you, because we're going to use our add-in card scenarios to explain this. But what I want to do is help you to understand that even though we have so many lanes to the CPU and so many lanes to the chipset, there's some obfuscation in how those resources are allocated because they're shared, where using everything becomes a conundrum. There's give and take, and that's what I want to show you. In essence, what's going to happen, let's take a look at the CPU and see how those resources are allocated. But what I'm going to start is with the manual with the specifications, and we'll be coming back to this layout. Okay, looking at the specifications for the CPU and the chipset, we're going to be looking at an Intel 13th generation CPU, and we're going to be looking at the specs for the chipset on the Intel Z790 chipset. The memory configuration we have are 4 DIMMs, 128 gigs of DDR5, supports the XMP profile, and if you notice, this says here, non-ECC, unbuffered DIMMs, which means that would be on-die. And I'll interject right now, if you're looking for support for ECC memory on DDR5, then the CPU will have it. We're going to take a look at that and reference it. The chipset does not have it. We'll reference that. And what you're looking for is sideband, which has the ability for parity. But the chipset you need for that, because you have to have 4 things to support it: the CPU, the chipset, the motherboard BIOS, and the RAM for it. You'd be looking at something on the W680 chipset from Intel. That supports ECC. We have another video we hope to do about that later on. Back to this. But we just wanted to point that out. And for graphics, we have a display port and 1 HDMI port. That's important to know. And the CPU has onboard graphics. Now, the CPU will support 4 displays. However, the configuration on this motherboard is for 2 displays. To reiterate, display port and HDMI. That's important. Specs. And when we get into the slots and storage, that's where things get interesting. Let's go check out now the CPU. This is the Intel i9 13900K. And what we want to focus on, right here, the total cores, 24 cores, 32 threads, 8 performance cores, 16 efficient cores. Memory specifications, 128 gigs, and on this chipset, on this motherboard, we're using DDR5. To reiterate, dual channel and ECC memory supported. And if we go to the question mark, and it will give us the information we're looking for. ECC memory supported indicates processor support for error correcting code memory. ECC memory is a type of system memory that can detect and correct common kinds of internal data corruption. Note that ECC memory support requires both processor and chipset support. So the CPU supports it, but we'll corroborate that the chipset does not. Okay, processor graphics. We have Intel graphics, supports DisplayPort and HDMI, and you can see the resolution through HDMI, 4K, 60 Hertz, and the resolution through DisplayPort, 8K at 60 Hertz. And if there was a resolution on an integrated flat panel, like a laptop, wow, 120 Hertz. Amazing. Now, expansion options. Right here we have a DMI interface, version 4.0, 8 DMI lanes. Just for a point of reference, CPU, chipset. DMI lanes are the lanes that connect those. So instead of having 4 lanes that connect the CPU to the chipset, we've got 8, which is great. So it should minimize latency. However, anything in that chipset, through those 8 lanes to get to the CPU. And there's a lot of stuff on that chipset that just kind of bogs my mind. But there's a lot of stuff on the CPU as well that we're gonna need more lanes than we've got. Let's keep going. And the maximum number of PCI Express lanes are 20. Now, PCI Express revision. The CPU supports PCI Express 5 and PCI Express 4. How does that play out? Glad you asked. Okay, 1/16 plus 4 is 20, or 2/8 plus 4 is 20. Now what that means is that 1/16 is PCI Express 5. That plus 4, which is an M.2 NVMe drive, is PCI Express 4. And in the same configuration, if you've got 2/8, that would be PCI Express 5. Whereas the plus 4 is PCI Express 4. That's how that works out. Now back to the specifications. Okay, expansion slots. And to reiterate, we're separating out CPU lanes from chipset lanes. So we're going to focus on all the CPU lanes that take care of that one slot, the primary slot, and those 2 M.2 drives. And remember, the configuration for 20 lanes is supposed to be 16 plus 4. Well, what's going to work out is we're not going to have 16 plus 4. We're going to have 8 plus 8, which is 16. Let me show you. Okay, PCI Express 5.0 by 16 slot with 2 stars. We're going to come back to those 2 stars. Now, the motherboard for storage supports 5 M.2 slots and 4 SATA ports. Remember, each SATA port is a PCI Express lane. Those are chipset lanes. The 5 M.2 drives were only concerned with M.2_1 and M.2_2. Okay, M.2_1 is PCI Express 5. M.2_2 is PCI Express 4. Got that? Okay, here's where it gets a little funky. Back up here for the CPU where we see those 2 stars. Right here, those 2 stars. When M.2_1, which is PCI Express 5, is occupied with an M.2 NVMe device, the PCI Express plus 16 G5 slot, which is this slot, will be by 8. Okay, well, how does that figure? If that's going to be by 8, and that's only needing 4 lanes, what happens to those other 4 lanes? They're not reallocated, they can't be reused anywhere else. And we're going to see this as a recurring theme as we look at some other information. I had to read through this several times myself to get the hang of it. So what you're hearing may be news to you. And anybody that's excited about the motherboard because it'll support 5 M.2 drives, only one, the primary, is PCI Express 5. All the others, the one to the CPU and those other 3 to the chipset, are all PCI Express 4. What's up with that? It's just the way it's allocated. It's not just the motherboard, but it's the CPU and the chipset, the way it's designed. Because anyone that's done the most for bifurcation of anybody to make that work on as many motherboards as possible is ASUS. And if ASUS has it set up this way, don't expect anybody else to do any better. ASUS will do the best job of anybody that anybody could do. I want to share that with you because we're going to go through this with the add-in card scenarios to reinforce what I've just said to help you understand. There's 20 lanes there, and it's limited on how we can use those 20 lanes. And if you use the default configuration, you're going to have an 8-lane slot. You have 8 more lanes where only 4 are used for M.2_1. You lose 4 lanes because M.2_2 is dedicated. To reiterate, M.2_1 is shared with that slot. And because it's a shared resource, even though there's 16 lanes and there should be 4 and 4, the math doesn't add up because we lose 4 lanes, which is a real bummer because I don't think we can afford to lose lanes. We need to add 4 lanes, not lose 4 lanes. So you're going to see how this plays out with 3 add-in cards that would work in that one slot, what we do. And to reiterate, M.2_1, which is shared, and then we go down the motherboard to M.2_2, which is all the way down here, and that's to the CPU, but that's dedicated. That's PCI Express 4. Only that slot's PCI Express 5, and that M.2 connector are PCI Express 5. And those are to the CPU. And also remember, only CPU lanes can be bifurcated. We don't BIOS bifurcate chipset lanes. We BIOS bifurcate CPU lanes. Another important thing to remember. Okay, back to our specs. Now, another note here with 1 star, please check the PCI Express bifurcation table on the support site. We're going to go to that and bring that up in just a minute. But I want you to understand about these slots, M.2_1 and M.2_2. Okay, for that slot, our add-in card scenarios, of which this time we're going to have 5, and only 3 are relevant to this one slot. Number 1, can we install a quad card? Yes, you can. What's going to happen? Well, we're going to go to the bifurcation chart, and it's going to reinforce what I'm getting ready to tell you. Because the slot, and we'll look at that in the BIOS and reaffirm that information, that slot bifurcates to by 8 by 8. Now for a quad card that has 4 M.2 NVMe drives, full bifurcation would be 4 by 4 by 4 by 4 to see all 4. 4 times 4 is 16 because each M.2 NVMe requires 4 lanes. However, because the slot bifurcates to by 8 by 8, you'd see drive 1 and drive 3. You will not see drive 2 and drive 4. Add-in card scenario number 2, what about a video card? Okay, as an option, if you're, say, using this as a DAW, it'd make a great DAW. You could use the internal GPU because you're doing CPU rendering. However, our number 1 requirement, because we're doing content creation video rendering, we need that video card because the video card can do 80% of the rendering. Therefore, we need that GPU. So if we put the GPU in that slot, 16 lanes, we cannot install M.2_1, which is PCI Express 5. If we do, to have one M.2 drive that's PCI Express 5, that slot goes to 8 lanes, which is fine for a GPU, whatever GPU you put in there. So that'll work. That's the default configuration. That's the best. Okay, add-in card number 3. What about a dual adapter? Well, you could put a dual adapter in that slot, but the problem is because of the bifurcation of by 8 by 8, you'd see 1 drive. So that's not a good use of resources. So I wouldn't try to put a quad card in here. I wouldn't try to put a dual adapter in here because you're only going to see 1 drive. Now, another motherboard that's counter to this that I'm going to show you, and I still think this motherboard is a better value for the price, utilizes the same resources but in a different way with the same outcome. In other words, instead of having 1 M.2 drive that's PCI Express 5 on the motherboard, they put it on an add-in card. So when that slot bifurcates to by 8 by 8, you see the first drive, that's all you need. But it has to be in the second slot. If that card is put in the first slot on this other motherboard, it's PCI Express 4. So there's all this give and take about resource allocations. This motherboard is a good deal for the money, but now that I've mentioned it, I'll put a link up in the description. I'll show you the motherboard I'm talking about. Now, our primary video is on this primary motherboard, and this is the ASUS ROG Strix Z790 gaming Wi-Fi. Disregard what that says about the price because that's from a different vendor. It's actually out of stock on Amazon, and Amazon would sell that at $500. Okay, I want to reference that to this other motherboard that I've mentioned, and that would be this one, which is the ROG MAXIMUS Z790 Hero. And the big difference is the things we've just explained. Now on this motherboard, Thunderbolt 4 is built onto the motherboard, whereas on this motherboard, Thunderbolt 4 is an add-in card, but you end up with the same results. We've got 3 slots. We've dealt with stuff on the CPU lanes. Now let's take a look at the bifurcation chart that's talked about here in the manual. Now we're looking specifically for that motherboard, the ROG Strix Z790 e-gaming Wi-Fi. And if you'll notice the way the information has been arranged, all of the Z790 motherboards that ASUS makes that can be bifurcated are on this chart. And I've never relied so heavily on this chart, probably in a long time, until I got to looking at this, and it was kind of an eye-opener. For example, PCI Express was 16G5_1, first slot, and that says PCI Express by 16 slot. Okay, on that slot, bifurcation, and it shows the slot and the M.2 SSD quantity, which is an M.2 NVMe, the distinction being 1 by 8 or 2 by 8 plus by 8. And the key for that is pretty much as similar as we look at all these boards. These are all Z790 motherboards, ROG ProArt Intel 700 series, the PCI Express by 16 slot, and how that's going to work. So if anybody has a question about a Z790 motherboard and about bifurcation, you want to look at this chart and see how that plays out. Every one of these is by 8 by 8. So that's an issue not with the motherboard, that's an issue with the chipset. There's a good example. The ROG Strix Z790F Gaming, PCI Express by 16G5, you'd see one drive, 1 by 16. Or with the ROG Strix Z790A Gaming, and we're focused on the ROG Strix Z790E Gaming. That's what Zeus had asked about. So as you go through this list and you get an eyeful of that, even down here with the Prime Tough series, Z790, you've got the same issue with bifurcation. You're only going to see 2 drives on a quad card. And that's why putting in a dual adapter is a bad idea. Now before somebody comes up and says, well, hey, what about the ASUS ROG MAXIMUS Z790 Hero? Okay, that has an M.2 card that has to go in that second slot. To reiterate, if that M.2 card, which is a single drive card, is put in the first slot, it will be PCI Express 4. If it's in the second slot, it'll be PCI Express 5. So the resources are just allocated differently. You have 3 slots, but remember this motherboard has Thunderbolt built on the board. Whereas the one we're looking at, the ROG Strix Z790E Gaming Wi-Fi, does not have Thunderbolt built onto it, but it can accept Thunderbolt. So I wanted to show that for somebody says, well, what if and what about? That's how that works. Every one of these motherboards is always different, but as I got a chance to step back and look at this chipset, it just really took me. Let's go look at the chipset and see what it says for the specs, because I haven't shown you that yet. We've only looked at 2 motherboards, and we talked about the bifurcation by 8 by 8 chipset. Okay, the Intel Z790 chipset and the essentials we want to look at. This reinforces the memory spec, 2 DIMMs, ECC memory supported, no. So that settles that. Processor graphics, 4 supported. We've only got 2. DMI 4.0, maximum number of DMI lanes, 8. And remember the DMI lanes are the lanes that connect the CPU to the chipset. Not 4, but 8. 8 lanes connects the CPU to the chipset. So everything in the chipset, that'll help minimize latency. That's a good thing. Now, PCI Express. The chipset supports PCI Express 3 and PCI Express 4. So how does that work? Okay. The M.2 drives are going to be PCI Express 4. The Thunderbolt card would be PCI Express 3 4 lanes if you add it. Even though the slot is PCI Express 4, Thunderbolt is PCI Express 3. And this is for Thunderbolt 4 USB 4 because it's Intel. And it's actually USB 4 version 1. USB 4 version 2 should be PCI Express 4 4 lanes. But right now, if we look at the specs, it's still PCI Express 3, to reiterate, 4 lanes. The lane count stays always the same. I just want to point that out. Now, we have 28 chipset lanes. That can be by 1 lane, or it can be by 2 lanes, or by 4 lanes. And our M.2 NVMe drives are 4 lanes each. Our SATA ports would be 1 lane each. Now, copious amounts of USB ports. And this is where things get a little weird, because I think there's some lane sharing going on, but I'm not real sure. So we're going to count that as we look at the motherboard layout and see what comes up. And we'll look again at the specifications and see how that plays out. Okay, motherboard layout. We've dealt with the lanes of the CPU. Now we're talking about the lanes of the chipset. And we have how many lanes? This says we have 28 lanes. Okay, easy count. 2 slots, _1 and _2. 4 lanes each. To reiterate, 16 lanes mechanically, but electrically 4 lanes. So that's 4, that's 8. Then we have 3 M.2 drives. M.2_3, M.2_4, and M.2_5. Okay, that's 4, 8, 12. 12 plus 4, 16. 16 plus 4, 20. That was a pretty easy count. Where's the other 8 lanes? Glad you asked. How many SATA ports do we have? Let's go back and look at the specs. And the specification summary says 4 SATA ports. So then you ask, what's the big deal? That leaves 4 lanes. And we're not through with storage. I'm going to come back to that in just a second. Okay, USB. We have 2 USB-C 20 gigabit ports, one to the front and one to the back. The one to the front can also be powered. Up to 30 watts power delivery, fast charging, but it, to reiterate, does not do 60 watts, which is kind of a bummer. Okay, if that were taking 2 lanes, and if the other one were taking 2 lanes, that's 4 lanes. So that gets in the weeds and down a rabbit hole because we've only got 4 lanes left for all those USB ports. And if we use 2 for a 20 gigabit port and 2 for another 20 gigabit port, where's the rest of the USB going? There's either some more lanes being used that we don't know about, or there's some piggybacking going on, some shared. And my guess, based on the way everything else works with this chipset, it's probably shared. Only way to test it would be to plug a lot of stuff in and try to do something with it and see what happens. Based on what we're seeing, I expect all that stuff is all bundled together and it's all shared. But I go so far as to count as far as we can, and what matters is on slots and storage, and however the rest allocation works out, it is what it is. Can't do anything about it. I'm just the messenger. But I want to point it out because to me it's a bit of a conundrum. So we have M.2_1 that's shared with the primary slot on the CPU. And then we have 3 M.2 drives through the chipset that are dedicated. And we have 2 slots that are also dedicated. And we have 4 SATA ports that are dedicated. So when you add all that up, 4 lanes left over out of the 28 for all that USB stuff. It just doesn't, to me, it doesn't add up. There's not enough lanes. So I've said my piece on that, but I wanted to share with you so you're aware of it. We've got some more information that we want to reinforce this with. Let's take a look. Now this BIOS manual is specific for the ROG Strix Z790 series. It's a little bit generic, but not as generic as some we've looked at in the past. First thing we're going to look up, bifurcation. And that gets us to this page, which says 72 in the manual. And right there is what you're looking at in the manual. PCI Express bandwidth bifurcation configuration. And that is, and I've got some stuff I want to share with you about the M.2_5 configuration that I haven't covered yet. Right here, PCI Express bandwidth bifurcation. We have 3 modes. Auto, run full by 16 mode. Split by 8 by 8, that runs the 16 by 8 by 8. And then by 16 mode, supports the by 16 mode, and the M.2_1 would be disabled. And the auto, that's the primary. But the bifurcation, that's the way to go. So that's the way things work for the CPU. We've gotten into the chipset, and I've got to tell you some more about the M.2 drive. Okay, how does that work on the chipset with those lanes? 4 lanes and 4 lanes. Easy done. Now, add-in card scenario number 4. What about if we want to install a capture card? The resource is there, but I would put it on one specific slot because of the add-in card, which would be scenario number 5, would be if you decide, you don't have to, but if you decide to add that Thunderbolt card, which is about $115, raises the price of that motherboard, then that gives you the option. Let's look at the slot. And for those that are wondering about the pinout on the Thunderbolt, it's in the manual. Just do a search for Thunderbolt, and there's the TB_header, and that'll show you the pinout. And down here underneath that pinout, the fine print, the Thunderbolt card can only be used when installed in the PCI Express 16 G4_2 slot. Ensure that you install that card in that slot. So in that slot right there is where you put the Thunderbolt card, and right there's the header to plug it into the motherboard to have BIOS support. And that's where you'd install your capture card. So 5 different add-in card scenarios. For $500, I don't think any of these motherboards should be over $500. But for $500, that's okay. What's a problem is if you go add the Thunderbolt card, whether you need it or not, if you add it, that's another $100. And I think when you get up in those kind of numbers, you ought to be looking at something like a WRX80 workstation where you've got more resources. Whether you use a CPU with a higher core count or whether you just need CPU lanes and chipset lanes, I think the WX80 is a better value. But for those that want to build on this platform, I wanted to give you a little bit of insight looking at that motherboard and seeing how the bifurcation issue is. The way that plays out, it's all about the chipset, the way that's allocated, and the CPU. There's not a thing we can do about it. If anybody could, it would be ASUS. But we saw that repeatedly on several different motherboards in the bifurcation chart, which is absolutely fascinating. Now on the specifications, something else here I found of note, which I found interesting, under miscellaneous, we've got an alternative PCI mode switch. And what that does is there's a physical switch where you can change from PCI Express 5, PCI Express 4, or PCI Express 3 with that switch, which I found kind of curious why they do that for whatever reason. But I want to point that out. And then one thermal sensor, which is the thermistor, and then of course the Thunderbolt header. Now let's go back to the BIOS manual because I've got probably 8 different points here I want to make for you. Number 1, we covered the PCI Express bandwidth bifurcation configuration. I don't like it, but it is what it is by 8 by 8. Number 2 would be the Thunderbolt configuration, and that gives us a chance to explore the next point, which is PCI Express tunneling over USB 4. If you've got Thunderbolt on your motherboard, Thunderbolt 4 specifically, and if you don't have that setting for PCI Express tunneling, then you don't have USB 4. That's what you're looking for. That is supposed to be the setting that gets those 4 lanes outside of the box. So you get your bidirectional bandwidth, but you get those 4 lanes outside, which is what you need. And there's quite a few other settings in here, a couple that deal with the memory apertures that you'll want to go through and set. But I'm just want to hit the high points. Now this next point I want to show you is the ASUS SPD. The SPD is the Serial Presence Detect chip. This allows you to view the DRAM information, which I like. Nice idea. They also have a MemTest 86 built in to the BIOS where you can test your memory. I like that. And for those that are interested about the hot plug feature, can you imagine an M.2 hot plug? SATA 6G, yes. But I need to show you something on the specs that'll bring that into focus. Under the specifications, under storage, if you'll notice, M2_2, PCI Express 4. All these _3, _4, and _5 are PCI Express 4. However, M.2_5 could also be a SATA drive, which is kind of fascinating because that's 1 lane versus 4 lanes. And there's a BIOS setting that deals with that. M.2 hot plug. And the M.2 setting allows you to enable or disable the selected port. And the M.2 configuration auto will auto detect the device, and there's no way to reallocate those lanes. They either use it this way or they don't. But to reiterate, drive number 5 can be SATA or M.2 NVMe. Kind of curious. And of course the motherboard supports Intel RST, RAID 0, RAID 1, RAID 5, or RAID 10. And there's more information you'll want to look at when you go to install your M.2 drives. For example, on the 2280 length. I'm not going to read all that, but you'll find it. Just do a search for M.2. Now another setting we want to point out, NVMe configuration, PCH storage configuration. And what you're looking at, it shows here M.2_5 in SATA mode, M.2_5, and M.2_5 hot plug, which is pretty fascinating. And then of course your SATA for your SATA controllers. Okay, moving back to the motherboard specification summary, we're going to take a look now at Thunderbolt. And this is for those that want to add the card. It's available, nothing to wait for. It's just been repackaged from the Thunderbolt 4 to Thunderbolt 4 USB 4. Anyway, that's the card, and it's available. So what we need to do is take a look at the document, which is the Thunderbolt 4 card compatible model list. Manual would be nice, but not in Chinese. And looking at that list, we have the Z790 chipset, and the motherboard we're looking at specifically is the ROG Strix Z790 gaming Wi-Fi. It's on the list. That's the compatibility chart. It has the Z790, the Z690, as well as the 590, Z590, and other chipsets listed that it will work with. And remember, that's a 14-1 pin header. So to reiterate, we think this motherboard, the ASUS ROG Strix Z790E gaming Wi-Fi, is better value at $500, even though you have to add Thunderbolt, than the comparable model with the same end results as the ASUS ROG MAXIMUS Z790 Hero, which already has Thunderbolt 4 built on. But the end results are the same. So I hope this helps you to understand about bifurcation, that we don't get the clean bifurcation we need for 4x4x4x4. We get 8x8 for 2 drives. So going through those add-in card scenarios and explaining it the way we did so you understand your lanes. CPU lanes and chipset lanes, I think it's a little bit confusing, and we had some more information we wanted to point it out. This by no means is everything, because there's a lot of settings on this motherboard in this BIOS, even just for memory, that could be a separate video. There's a ton of stuff in that motherboard manual, and there's a ton of stuff in that BIOS manual. But going through all this documentation, where normally we have 2 pieces, the motherboard manual and the motherboard BIOS manual, this time we had 4, to show you the how, what, and where on how BIOS bifurcation works according to the bifurcation chart, which is a real eye-opener when you zoom in and zoom out on that. It's got a lot of information about Z790, so they're all going to be the same. And we went through the Thunderbolt chart, so all 4 of those. So I hope this helps. I want to thank you guys for watching. Welcome. This is BuildOrBuy. My name is Gil Boyd. We look forward to seeing you next video, Lord willing. We're out.